Greetings and or salutations, nerds. Episode 23. My hope is that we will be talking about... Why does it just say my stream is coming up? There we go. My hope is that we will
Episode
be
23.
talking about the Brower Group today. But I think there's a little bit of work yet before we get there. The stream's pretty laggy today, hey? Maybe it'll catch up. Brownie groups, yeah. Who doesn't like brownies? I still got to solve the crowded window problem. I definitely got to get another monitor or something. Okay. Definition of the Brower Group. Well, we're not there yet. It's like Groundhog Day, yeah. Yeah. Brower Group every day for the rest of time. I do think we can maybe get to the definition by the end of the episode, though, this time. I looked at what there is to see. I gotta hang on. Okay. Let A and B be k-algebras. We've got a tensor product of algebras. We have a copy of K sitting in there, which makes the tensor product a k-algebra. Basic stuff, normal stuff. And that they are associative, isomorphisms, blah, 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 blah. If we tensor up over A, we get A-valued matrices. To see this, note that a ring B containing a subring... So this is the... Is this supposed to be the ring B? Containing a subring R in its center is isomorphic to M and R if it only admits a basis like this as a left R module. Are we supposed to just know that? Let's maybe do some writing. We haven't done enough writing. If we do some writing, we may not make it to the definition of the Brower Group, but... So let's see. R is contained in the center of B, and then our claim... our claim is that B is isomorphic... No, it doesn't seem too far-fetched, but, there's so many things that I've just skimmed over, I feel like I need to do more writing in this series. This is isomorphic if and only if it admits such a basis. So certainly if it admits such a basis, this is true. I think I believe that. I think I believe that. What's going on? This is... Oh my god, this is pure chaos. I did not intend for this to happen. Now that it has, maybe this is the solution. Is that too small on the screen though? Like if I put this here and I grab this and nope. I don't know if this isn't going to give me enough room to write. Well, we could try it. It's like usual generators and relations for presentation of the matrix algebra. Sure. But this if and only if statement, like I definitely believe when he says, oh, you take this and that will be such a basis. But now to say, oh yeah, okay, I guess it is a if and only if. Okay, maybe it is obvious. Because if it is isomorphic, then of course you can choose such a basis. And if you can choose such a basis, then you build the isomorphism out of that basis. Okay. Okay, more generally, we can actually pick up tensors inside of here. So if we have A prime valued matrices, we tensor up with A, we'll pick up A. Hello from Germany, Johann. Guten Tag. Wie geht's? Oh, glad to hear you're a big fan of that series. I may return to it at some point. I don't really have that many viewer submitted proofs anymore. But there's a couple that people have sent me. So I may do that. I may also review Vixra papers in detail. Maybe I should also review more good papers in detail too. For any M and N, the product of matrices will be this. The tensor product of matrices will be this. Yep, I agree. Oh, but this is a neat way to explain it, other than doing normal linear algebra mumbo jumbo. We use the previous theorem to get matrix valued matrices, which gives us like the Kronecker product. So that's cool. I like that. Yeah. Did I have to? I don't know if I had to issue a public apology. I mean, it was only a handful of comments, and actually, a lot of people have commented on the new video that they are, they want me to go ahead with more Vixra review papers. So yeah, but I think what I need to do is, if I'm gonna keep going ahead with reviewing it, I just need to do a more honest takedown of those videos. Although that is quickly becoming the most popular video on my channel, and I don't know if I like that. My Who Gives a Sheaf was the most popular video on my channel before, and I liked that as the forward face of my channel. I should do a Russian roulette, either Vixra or modern day algebraic geometry papers, or just some topic, I don't know. That would be fun. There is this website, I don't remember what it's called. I used to have it saved, but what was it like? I think it was like Snarchive or something. Yeah, I'm sure we've talked about this on the channel before. So basically you have to guess whether, and this is a very old site, so this is like pre-AI, like which makes it all the more impressive. And so you have to guess which one is a real paper, and which one is not. I think this one's real. Nice. Consistent quantum expansion around soliton solutions. Or progress in n equals m supergravity. This one. Oh, I was wrong. I almost went with the other one there. Yeah, anyways. So you can see I'm only about as good as a monkey discerning the titles of papers that are real versus not. So yeah. Okay, I messed up my whole setup here now. Probably slightly easier for a physicist. Probably one would hope that perhaps. Let's see. For some reason, I like seeing the colored name bubbles, the profile pic bubbles, but maybe I should just give myself more room here. You feel like actually physicists would overanalyze and get them more wrong? Maybe I got to have a physicist on here to play the game with me. Okay, centralizers in tensor products. We've got two k-algebras with b subalgebras. We look at the centralizers of those, and then the centralizer of the tensor product should be the tensor product of the centralizers. Don't you just love it when that kind of thing works out? So certainly this will be true. Yes. Yeah, I have very loud upstairs neighbors. Or does everyone have very loud upstairs neighbors, right? People talk about this all the time, and I'm like, maybe I'm loud to the people beneath me. But I don't think so, because these people they definitely are in their house with their shoes on, like psychopaths. Yeah. I've been thinking when I move, for a postdoc or a job or something, I think I'm going to have to be in a 3-story building and be on the top floor of the 3rd story. I think that's the ideal for me. You have loud upstairs neighbors and you live in the top floor. You might want to talk to someone about that, Arad. Average mathematician thinks normal people are beneath them. Yeah, that's the real reason. I just need to be above everyone. I mean, most of the grad students are on the 3rd floor. In our department, and most of the profs are on the 4th floor, and actually a lot of them are on the 5th too, but I'm up on the 5th, and you bet your ass I jokingly rub it in to my friends and colleagues. Actually, by the way, because we're on the 5th floor and we study p-adics, we often refer to our office as the PATTIC, the P-attic, because we're really cool and fun like that. Okay, let's go the other way around. So we got a basis for a prime, and this should be a basis for this as an A module. And so an element alpha can be written in this form. We take a random beta in B. Alpha commutes with this if and only if each of the alphas commute. That's believable, but I'm weirded out by like simple tensor nonsense, right? So alpha is the sum of alpha i's, tensor f i's. So alpha beta, beta alpha. I mean, beta is in B, right? Oh, alpha commutes with beta 1, right? I should shrink my face? Oh, maybe. Let me see how this looks on the thing. Oh, I guess but I can't see that. But my big, beautiful face. Maybe I should, though. I need to find a better solution to all of this. That's a good question, Drip. I actually, and it's interesting you asked that question because actually, I, in the course of writing my thesis, have been writing it out. For me, the decision is, so first off, I guess there's a principle in writing that suggests just write things out. Especially nowadays, like I think there was a time when there would be a suggestion to maybe rely more on abbreviations, especially for long things when you had to like type out what you were writing, and there was limited space in journals and something. But now on the computer, it's very quick. It doesn't really take me that much extra time to write out the full word to just be more grammatically proper. So, for instance, in an earlier draft of my thesis, I wrote PKLH for the Piatek-Kasdan-Lustig hypothesis, but I'm actually just writing the full thing out. And so for me, if IFF, it's too close to F, right? Like, of course, I write IFF if I'm writing on the board and I'm like giving a tutorial lecture for my students or something, right? But to me, I just want to make sure that I'm driving the point home that I do mean if and only if. And if someone's reading it, doing a quick scan, you know, it's a lot easier to conflate one F versus two Fs. And so for me, personally, I think I would both prefer to read and I would prefer to write to whoever's reading my thing the full if and only if, just to be perfectly clear. Make each implication its own theorem, yeah. Yeah, it's a matter of formality. No, Mr. L, that's even worse. I wouldn't say that. So I wouldn't say that's quicker yet because that just takes more characters to code in LaTeX unless you, because you have to, even if you make a shortcut, right? Even if you make a shortcut, we got like, so you could do $IFF. Maybe you make an even shorter shortcut, but if you had somehow just a one letter thing, I mean, this is still 4 letters as opposed to this. But no, do not. I mean, this is a big no-no. I tell my students all the time, stop. Do not mix, like if you're going to have some sort of, you can have a formula, right? Where you can write in like display mode, like A is an A, if and only if, A plus 1 equals B or something, right? But do not put symbols like this. Do not put this. Do not put this in the middle of an English sentence with words. This is bad writing. You always say that for contradiction? Yikes. What? Really? I mean, I kind of like the idea. I like the idea of this symbol. I don't know about using it in practice. But I do like the idea of that symbol. Or that. I mean, that is kind of cool. I would maybe use that. I like this. I like the broken, the squiggly exclamation mark. Squiggly exclam. Ken refereed a paper earlier this year where the authors used logical symbols in their theorem statements. Yeah, that's bad. I mean, it depends. I mean, I guess I would need to see the context. I think you could. I don't think that's necessarily wrong, but depends how and where they're placed, I guess. Oh, handwriting or on the board, then yeah, absolutely. I gotta make some tier list videos, by the way. Tier list of math symbols and stuff. Okay, but hang on, where was I? So we're trying to commute, beta 1 alpha with alpha beta 1. And so we have beta 1 and the sum of alpha i's fi's versus the sum of alpha i's fi's. Yeah, this is the worst of all worlds, this weird display I've got going on. Is there any way I can shrink this bar? Oh, I made it slightly bigger, dear Lord. Yeah, okay. So then what have we got? We've got the sum of beta alpha fi compared to, oh yes, I guess, right. I see. I agree. Because in this case, the fi are, because we're dealing with a k-algebra basis, we don't have to worry about things so much with the weird torsion things happening. I think logical quantifiers are okay in some cases, set builder notation, but not in the middle of English sentences. Yeah. Yes, exactly. I absolutely agree, Ken. Yeah. Okay. Yeah. So where are we here? Therefore, the centralizer of B1 in here is this. The centralizer of that is that. And so this is contained in there. Right. Right. Okay. Nice. I believe it. You once read an Australian math paper, and they had logical quantifiers everywhere. Gross. In particular, the center of the tensor product of two algebras is the tensor product of their centers. I mean, what kind of world would we be living in if that was false? The center of a simple k-algebra is a field. Interesting. I think I knew this already. Previously, the center, obviously, what am I smoking this morning? The center of a division algebra, obviously the center of a division algebra is a field, but Wedderburn's theorem shows that every simple k-algebra is isomorphic to this for some division algebra, and now this is isomorphic to this And the center of this is this, which is isomorphic to the center of D. Is the center of the division algebra. Wait, so what was the takeaway there? Hang on. I mean, we know that our simple k-algebra is isomorphic to this. Oh, right, yeah, and that's a field. Yeah, okay. You IRL saw someone who could write perfect fractor with chalk. Wow. We need to find some equivalent of the Fields Medal for that. That's incredible. And could they do it? Could they do it quickly, like in a reasonable amount of time? That's the dream. I feel like I got to start studying calligraphy and know how to do that. Your commutative algebra prof could do this. You never understood it. Yeah, neither do I. Yeah. Maybe I gotta go to Germany for a bit. Johan. That was your name, right? Earlier in chat? Yeah. Help me get to Germany for my postdoc. I need to study under someone to make good fractor font. K-algebra is said to be central if its center is K specifically, and a K-algebra that is both central and simple is said to be central simple. Makes sense. The corollary shows that every simple K-algebra is central simple over a finite extension of K. Hang on. Why does that say that? Why does the corollary say that? It says it's a field. Oh, I see. Does K and K necessarily is a subfield of this? I'm tempted to believe it. Yeah, I guess so, because you just look at the K diagonal matrices in there. Okay. I guess this is an important point. You once entered an interview room and they had whiteboard. You nearly crowed. I don't know. I like whiteboard. I like chalk too. It was romantic. But definitely when I was doing a lot of climbing, I was constantly thinking about the amount of chalk dust I was inhaling on a daily basis between the climbing wall and the classroom. Wow, okay, I was wrong. We went too slow, and now we're still not gonna make it to the Broward group. I'm teasing people every day with the title, and I'm gonna call it Broward group tomorrow as well. Primordial elements. Before continuing, it will be useful to review a little linear algebra. Wait, haven't we been doing that for like 20 pages? From the second edition of Bourbaki. Kind of a failed bachelor's student, so you don't know how much you can help. Well, maybe we'll find some way to reunite together in Germany. I'll somehow get there, and then I'll find a way to help you re-succeed in your bachelor's, and you can help me write fractor font. I don't know. You did call it a rod, yeah. Some profs wear dark pantsuits just for the chalkboard dust swag. Yeah, I need to do that more consciously. New Wave Infantry, I'm glad to see you back. I thought maybe after your comments on my Vixra video that maybe you had left the channel, because I hadn't seen you since then. So I'm glad you've returned. Why are there so many definitions of automorphic forms? What's the one I use? Are there a lot of definitions? I don't even think I could define it for you right now on the spot. What is canon in automorphic forms to you? I mean, isn't it? I don't think I could pull it. I don't think I could pull it out on the spot right now. But, yeah. What's the? I'm trying to think. I mean, the full space of automorphic forms. I think I refer to bump, so it's like. No, I can't even tell you right now. Oh, it's just a weird time for you. Okay. Well, I'm glad you haven't abandoned me completely. Where's bump? I think this is normally. Let's go here. This is not the bump. This is bump at all. Whoa. Yeah, we're really taking our time with with Milne these days. Oh, you know what I should do is maybe if I downloaded the PDF, it would make skinnier margins. No, I don't think so. Let's see. We got bookmarks here. No, we don't got bookmarks. You also join whenever you have a question. You've asked most of the things. Fair. Yeah. Yeah, I mean, okay, this is not me. I guess this isn't a very original answer then, because I'm looking it up. But this, I do think of bump's definition, just because I'm familiar with this book. Where would it be? Modular forms to automorphic representation? Or maybe it's in Kudla's article. Maybe it's in Kudla's article here. Right. Typically divide out by the center, or that AG thing. Yeah, that's what I'm thinking of. The Wikipedia page for automorphic forms is confusing. Okay, I'll check that out in a second. Well, but the things you say there are all sort of the same, no? I mean, you do necessarily need to view it from the form of Lie groups and complex analysis. Oh, I think I see. I think I see part of your meaning, though, because there is the case where you can embed, for classical modular forms, you can talk about it just at the level of real groups, right? But I mean, for me, I think the definition that makes the most sense is like the adelic one, because that encompasses basically all of them, right? So for me, that is the definition. Yeah, I probably should just use Control F, but you know what, we're here. Yeah, the space of automorphic forms is this. Well, that's with a prescribed central character, but whatever. Yeah, so the space of automorphic forms on GA with this central character is a space of complex valued functions on GA, such that we have this transformation rule for every finite adel. This thing is smooth. This determines the smooth function on the Lie group part. Yeah, I mean, this is the definition that I think of. The legendary inventor of the bump function. Yeah. Let's see, what does Wikipedia have to say? Automorphic form, well-behaved. Okay, I mean, that's just the loose definition. Definition. Okay, so first, again, just sort of discussion, like talking about factor of automorphy. They don't really give a rigorous definition, actually. History, automorphic representations. Yeah, they don't even give a definition, the proper one. That's part of the problem. What did they say here? A more straightforward but technically advanced definition using class field theory. I'm not familiar with a definition that uses class field theory. Wikipedia has so many little errors. I mean, I don't know. It's often pretty good for math. I find. Just maybe not this article. How do you define GAF for an algebraic group over F? Is it G times? I do think there is some subtlety here that I'm not remembering. But I mean, AF is just a ring, right? So you just define a group scheme, and I was about to pop open Getz and Han, actually. Yeah. But yeah, I guess it is this big beast of a ring, so. Yeah. So much yappa in that article. Yeah. Okay. Wow. We really haven't even come close to where we wanted to get today in this. Let's look at primordial elements. K vector space, possibly infinite dimensional. This is a basis. Any V can be uniquely written as this. And we define JV to be the indices which are non-zero. Sure. A non-zero element is said to be primordial relative to the basis if JW is maximal among the sets JW prime for W prime a non-zero element of W. And in the expression, at least one of these is equal to 1. Is it even true that this has a minimal? I guess if the space doesn't have a minimal thing, then it doesn't have primordial elements. Yeah, evaluating schemes at topological rings is quite subtle. Yeah, I mean, I figured as I was saying it, I figured that probably there is some subtlety involved, right? I mean, especially if you think about the fact, I mean, even in the case of G at a p-adic field, right? I mean, we talk about it as an algebraic group, right? And we talk about it, oh, it's a reductive group, and we talk about like group schemes. But then the topology we put on it is actually totally different. So, you know, there's freaky things going on there. WB non-zero element such that this is minimal. Why do these primordial elements matter? That's my question. I don't really care. Okay, let's just read the proposition. A WB non-zero element of this such that this is minimal, and let this be a second non-zero element. then this is true if and only if this. I don't know. I'm just going to skip this proposition because I'm not very interested by it. Is GF the same as G then? Is it just the closed points? Does it depend on F being algebraically closed? No, it shouldn't. No, it won't depend on it being algebraically closed. Well, okay, actually, this is an interesting point. Is GF the same as G? Well, no, because you should, I guess if you're doing this sort of the right way or the modern way, right? Like you would define G in terms of a functor of points perspective. So, you basically define G as some sort of functor, and then GF would be the F-valued points of your group. And so certainly F does not need to be algebraically closed. I mean, generally, I'm interested in studying GF for finite extensions of QP. But definitely check out Getz and Hahn. That's the thing to check out here. Simplicity of tensor products. Yeah, I guess this is where we'll start off tomorrow. I think we might call it here. Well, let me look at Getz and Hahn. Let me look at Getz and Hahn. Affine group schemes. Is this what we want? Yeah, I mean, this is just general functor of point stuff, but I wonder where the Adels come in. I guess I could just control F to the Adels. Well, I guess it wouldn't be until after they introduce the Adels, right? Adels. Adelic points of affine schemes, yeah. So let's take a look here. Vey and Grothendieck both gave approaches under different hypotheses to topologizing the points of schemes of finite type over a topological ring. Conrad gave a beautiful exposition and elaboration in here. The naive idea is as follows. Given a topological ring, Rn inherits a natural topology. Given an affine scheme, we choose a closed immersion here, which induces an injection here. And since we have endowed Rn with a topology already, we can then give Xr the subspace topology. The problem with this method is that it is not clear that the topology on Xr is canonical, and it is not clear that it is functorial with respect to morphisms of affine schemes. Conrad refines this naive approach. He abstracts axiomatic properties. We would like the topology on here to have. Proves those properties, uniquely characterize it. So theorem, there's a unique way to topologize XR for all affine schemes of finite type over R, such that the topology is functorial, topology is compatible with fiber products, closed immersions, things that we would want. Yeah. What's like a good way to rapidly learn the basics of representation theory of finite groups for qual prep? You've seen Art and Vedderburn, stuff like Mackey's, sure, randomly, not in an actual course, just solve problems and learn backwards. Yeah, solve problems, learn backwards. I mean, you should be able to compute character tables of groups, I would say. Definitely, if you look at books like, look at Fulton Harris, there's look at how they, like go through the proof, they go through the proof of constructing the character table for A4, for example, and sort of see how they do it. You do some like guessing and checking, and then you're like, oh, here's some missing columns, so I will try to, use like tensor products and symmetric products and wedge products to create some new characters, and yeah. So I think actually that's a great thing. So like as a single project, like, look at their approach to doing this, and then maybe try and do like A5 or S4 or something, right? Because if you go through the process of trying to like determine the character table of a group, you'll probably end up just like developing, like you'll need to rely on a bunch of tools like character theory and tensor products and like stuff like this. I don't know, but it depends on the qual. Like, I don't know, are they doing like mod P rep theory as well? Like, I don't know. GNA is just so this is the group, this is the additive group. So basically, but this should be a functor, right? So like GA, we basically think about this as like your field, the additive group of your field, right? So this is basically just like affine space, except now we want to take the functor of points perspective, right? So this should really be of I mean, I guess we could even take like the coordinate ring, something like this, and then if it's n, like this would be n variables, something like this. Or did I put the hom in the wrong component? I'll probably put hom in the wrong component. Galois cosmology, yeah. Let's study Galois cosmology next. Oh, I put it in the right component. Look at that. I am a genius. I am the smartest man that ever lived because I remembered one thing that I'll probably get wrong, like when I read it tomorrow. God, this office hour has been so long, and we've done none of the reading we're supposed to do. Wow. Real math moment here. Yeah. Anyways, let's actually end stream, and maybe tomorrow we'll get more work done. Or not. Maybe I will yap about dumb things. Wow, has my audio been spiking that hard this whole time? Okay. Anyways, time to go prove stuff. So QE